In the previous video, we began our journey trying to find the probability that the mean weights from the samples are more than 6 grams apart from each other. And to do that, we started studying, or we started thinking about, the sampling distribution of the difference of sample means. And we figured out the mean of that sampling distribution, we figured out the standard deviation of that sampling distribution, and we were able to establish that it is normal. So that the sampling distribution of the difference of sample means will look something like this. So it is normal, so it is going to have that classic bell shape like that. We know its mean is at 5 grams, so this is 5 grams. And we know that a standard deviation is roughly 0.79 grams. So this is 1 standard deviation above, maybe 2 standard deviations, 3. This is 1 standard deviation below, 2 standard deviations below, 3 standard deviations below. This right over here would be 5.79 grams. This over here would be 4.21 grams. Now, if we want to find the probability that the mean weights from the samples are more than 6 grams apart, well, remember, this is the difference between the sample mean from A and the sample mean from B. And so there's one situation where A is more than 6 grams larger than B, or our sample mean from A is more than 6 grams larger than the sample mean from B. And that would be this area right over here. If 6 is right around here, it would be that area. But there's also a possibility that the sample mean from B will be larger, will be more than 6 grams larger than the sample mean from A. So if you really were to extend this far to the left, and you're really not going to be able to see it much like this. So if this is 5, maybe this gets us to about 0 right over here, and then you're going to get -6 someplace out here. There is some area under the curve where this difference is more negative than -6, or another way to think about it, it's less than -6. So to figure out this probability, we need to calculate both of these areas. Now you could do that with a z-table, and we've done that in many examples before, or we could use some type of online tool or online calculator. So this is at a site stapplet.com/normal.html, and what we can do is, we know we have a normal distribution that has a mean of 5 grams, a standard deviation of 0.79, and then we can plot the distribution. There we have there. And then we can calculate the area. Well, we could calculate the area outside of a region. And then that region, the left boundary would be -6, and then the right boundary would be 6. And then if we calculate that area, it is, you see the right boundary right over here, or the part that's greater than the right boundary, but there's a little bit, it'd be negligible, that's far to the left that we're not seeing as well. But there you have it. That area, which is mostly the one that you're seeing here visualized, you're not seeing the one on the left, it is 10.28%, the combination of the two. And so that's our probability. Our probability, we just found it, it is 10.28%, and we're done.